Hello, my name is Vitaly Honchar, and in today's video I will show you my new project which I built to manage IoT devices in the local network with a platform in Go for Raspberry Pi, which runs again without any cloud deployment, is completely secure and is able to collect telemetry from IoT devices and execute some remote commands. For today's video, I built a simple project with ESP32, which emulates a real device which sends some telemetry data and allows to run some command, and Raspberry Pi, which runs server developed in Go. So let's jump to the demo. Before we will start, I want to say that this project purpose was to have lightweight deployment of IoT management system, which will allow to very quickly connect different devices, collect metrics, and visualize them with customizing for client request in very easy way. So on this screen you can see main dashboard, facility network health, which was built by me for this demo. So because platform is super flexible, it allows to visualize any graph, any data collected from device. It works like Grafana, but it's developed by my hands and runs on Raspberry. So here you can see the graph for connected Wi-Fi RSSI. So probably it's strength of signal, I'm not sure. Also there is strongest AP access point, which this metric ESP32 sends me to the server, and we have here visualization, and also we have different tables and everything else. We can do like in Grafana scaling of graphs and see what actual value was at what point of time. And this home dashboard is completely configurable. If we will go to the dashboards page, we can see here a list of dashboards available in the system, and we can click here on facility network health. We will see the same dashboard, but with one exception. This dashboard is a home dashboard, and at home, when you open this Fleeto from your Raspberry Pi, you can see this home dashboard by default, so it makes sense to build some command center dashboard, which will show main metrics, will show you some forms to execute commands on device. For example, here we have scan now button, and command was sent to ESP32 to scan my local network. And to add a new device to this platform, you need just configure a new device, specify telemetry schema, the JSON schema, command schema, and then connect with MQTT to this Fleeto platform on Raspberry. To connect with MQTT, you also will need to use the certificates which you see here. They are generated by system, so we use mTLS connection, which means that traffic is encrypted, so nobody will steal traffic which will be sent from IoT device to server. And here you can see that device is online and list of messages from this device. So here we send some command. Here we have result from the device, like result OK. And if we will see telemetry raw message, it will be just some raw message. And this raw message is in JSON for simplification of visualization, but the protocol which was used between IoT device ESP32 and Raspberry Pi is binary protocol, which means that usage of traffic is slow, which is important for IoT devices because from time to time they are deployed on with mobile networks, so it's not JSON, which use a lot of traffic in comparison to the binary protocol, but at UI I use JSON visualization. But anyway, it was a demo of the product, so if need add more devices, it's possible to add more devices. It's possible to group devices by facility, like for example here I have one facility home with one my Wi-Fi scanner device. And it's possible to visualize any data which comes from a device. Also, if we speak about visualization, here I was inspired by Grafana when I was building this dashboard, and if you will click edit, here will be this JSON definition of the dashboard, which contains basically widgets like in Grafana or Datadog with queries to database and projecting of data and specifying the type of widget which we use. Right now it's support. I have support only for table and line, but in the future probably we'll add more widgets. So again, it's super flexible. If you need something completely what you imagine, you can build it here with this JSON definition, because it works like in Grafana. And this is everything about product demo. Let's go to the project architecture and see why this project is special. So first of all, let's go to system design. This Fleeto deployment is local first, so I don't have cloud, at least for now. Fleeto is deployed to Raspberry Pi here, and all devices are connecting via MQTT with mTLS to my Raspberry Pi server, and Fleeto saves all metrics to the database. And here was used embedded database SQLite to collect metrics, and embedded MQTT broker Mocha to build MQTT, to add MQTT support, which is very good, because other projects for IoT device management are cloud-based with heavier infrastructure, and if you need to run cheap IoT management system, it may be problematic. Also, I have web server on Fleeto, which provides user a possibility to use UI of Fleeto. And let's go next to main features. Main features are secure device connection via mTLS, private deployment without cloud risks, because again, cloud risk is, if cloud is hacked, all devices are hacked. That's why if you want to launch something at your home, some IoT automation, it makes more sense to launch privately in your local network than go with some cloud solution. Also, it is fully customizable for client needs. So if need, it's very easy to change visualization of the project to visualize widgets, graphs, tables, and if need, it's possible to apply custom styles to fit company brand which wants to use Fleeto. So it's subject to discussion. If you're interested, just drop me a message. We will discuss how to do it. And let's go next. According architecture and tech stack. So according tech stack, I was using Go as primary language for backend, Mocha as MQTT broker because it's embedded MQTT broker, SQLite as a database to save metrics and to save configurations for devices and dashboards. And here I split SQLite to one database which was handling telemetry data, which is write heavy, and another database file to maintain settings, which is read heavy. And as far as SQLite is a single thread, and also it allows to add some optimization with enabling wall and other things. I think it's a better approach to use SQLite, but if you are interested in more detailed explanation from technical side, you feel free to check my website. I also published it today a blog post, so feel free to reach it out and read about architecture decisions. But right now let's go back. So first of all, my idea was that in the future I will add support for cloud deployment. So I think that there is use cases when local deployment in Raspberry Pi will be not enough, and I will need to have cloud deployment. And for cloud deployment I need to replace some key components which prevents me from the scale. It's first of all MQTT broker, and database, because in cloud deployment with scale it's not a good idea to use SQLite because it doesn't allow to scale, and MQTT broker also should be used those which will provide me possibility to scale. That's why I was using software architecture from the DDD world with name clean architecture, onion architecture, hexagonal architecture. It has different names. I usually name it clean architecture, and it means that application is split by three layers. Is infra layer, up layer, and domain layer. Infra layer contains all infrastructure logic which belongs to the database, brokers, web, REST, everything else, but it doesn't contain any business logic. And up layer contains business logic, contains logic how to connect models together from domain layer, contains some logic to performances, models, and etc. And domain layer contains core classes which can be used by up layer and infra layer. But the key thing here is dependency rule, which says that infra layer, this one, can depend on up layer and can depend on domain layer. But this is one direction dependency. But domain layer can depend on up layer and can depend on infra layer. This is required because if you build system in this way, you can very easy to change infrastructure without changing up layer and domain layer. And in my case, it's especially what I want to do. I want to change infrastructure for Raspberry Pi deployment and cloud deployment. That's why I use this architecture here. And here, how it looks like, what I want to do. So right now, we have this Fleeto Raspberry Pi in with Mochi and SQLite as infrastructure layer for database and MQTT broker. We have these dependencies between layers, and what I will do, I will basically just change MQTT and database layer to Postgres and to NATS. That's all. I will not change. So the rest of code, this one, will be unchanged. So it's very good architecture approach in my case, because it allows to build very flexible applications. Actually, I use it in majority of my applications, but anyway. So I think that's almost all. Let's go next to the roadmap. So right now I am at the stage of prototype. I have working prototype. I have one idea what to build for my home automation with this project, but I want to finish development of this project first, finish V1 by fixing some bugs, maybe do some minor improvements, we'll see. After that, I will add bug support, because I know that users want to have possibility to control what user can access what device, So it's important to add. Also after that, add backup support. Because as far as you remember here, in the local deployment, all data saved in the SQLite, it's very easy to lose this data, but if will be backup support with AWS S3 or something like that, it will be a much more reliable system. And at the end, I will add cloud support. Actually, again, adding cloud support is super easy because of this architecture and my knowledge. So I think that's all. If you are interested in this project, feel free to reach me out and we can discuss opportunities to use this project in your production. I will be very happy if you will integrate some device with this system and try to use it. Again, reminder that right now this system runs on Raspberry Pi 2 0V, so basically it's board which costs 30 euros, and it's super powerful nowadays. If system developed correctly, it's possible to close many issues with IoT system. Thank you for listening to me. See you in next video. Bye.